This screen demo shows how to visualize the inside of a three-dimensional solid model, using a clipping plane. Let's start by choosing Contour Item, from Post-Pro menu, then select Normal Strain X Item. The distribution of strains in x direction, that is, epsilon x, is now expressed by the contour image. The strain contours are rendered on the boundary surfaces only. Then, how can we expose the strain distribution inside of the volume? Click the Clipping Plane tool. A square box is drawn, to surround the whole part of the model. The clipping plane is defined in the middle of the square box. The contour image is clipped by the plane. The contour is rendered on the clipping plane as well. Thus, the contour image on the clipping plane reveals the stress distribution inside the volume. We can move the clipping plane back and forth by mouse dragging. Currently, the clipping plane is set normal to the x-coordinate axis. The direction normal to the clipping plane can be reset by double-clicking an edge of the rectangular bounding box. Double-clicking the edge, parallel to y-axis, makes the clipping plane normal to y-axis. The plane can be dragged in the direction of y-axis. Keep placing the cursor on the clipping plane, while dragging, in order to make movement in parallel direction. Double-click an edge parallel to z-axis, then the clipping plane is set to normal to z-axis. In the same way before, the clipping plane can be dragged in the direction of z-axis. The clipping plane can also be made inclined in arbitrary direction. Instead of dragging the plane, with the cursor inside the plane, click an edge of the plane, and drag. Then, the edge of the clipping plane moves, and the plane becomes inclined following the edge movement. It should be noted that, the clipping plane always faces frontward, in the contour image. So, the displayed part of the model is switched, so that, the clipping plane may face frontward. The clipping plane is kept facing frontward, while, the model view is being rotated. So, we can always observe the contour image, on the clipping plane. We may alter the form of rendering the boundary surfaces, while maintaining the contour image, on the clipping plane. There appears a new menu at the end of the menu bar. The menu has a number of items related to clipping plane. Select Shading item from the menu. Then, the boundary surfaces are represented in the form of shaded image. We may do the same operations, as before. There are a few other options of rendering the boundary surfaces. Let's try Transparent item. The boundary surfaces are rendered as translucent objects. Choose Mesh item as the most commonly used option. The boundary surfaces are represented by finite element meshes. Let's choose Outline item. Outline option is effective in simplifying the scene as a whole. As the last option, we may hide all the boundary surfaces, and leave the clipping plane only. This is the end of the tutorial about the usage of clipping plane.